Larry, over to you.
I love coming here, and I love getting introduced by Troy, because at Rally, I'm the smart statistics guy. Here, I'm just the guy with lots of data, because I've got lots of other smart statistic guys here. So intuition, folklore, anecdotes, these are the ways we've been making decisions and recommendations in the Agile world for a while. I'm here to start you on a new journey, and I don't quite have the shtick down yet for the mystery novel, the mystery magazine comic book yet, but I got to get the hat, and the next time I do this, I'll do it. But imagine we're trying to solve a mystery here, and we're going to walk through figuring things out with evidence and replacing that folklore, that anecdote, with evidence and facts. Some of what I'll say here might not align with your beliefs, and I'm going to allow you to ask those while I'm going through, but I may quickly sort of say, let's save that to the end, because I want to get through all of it. The other thing I want to say is that not everything I give you is going to be causal, and I know that. I'm going to give you correlations, and we'll have to use that as evidence as best we can. In cases where I can rule out common cause for both the x-axis and the y-axis, I'll try to point those out to you. Or cases where I'm not sure, I'll try to point those out to you as well. A little bit about my background, though, for those of you who haven't heard me speak before. I graduated from Virginia Tech with a double-E degree. I did my first startup before I actually graduated. It grew it to 80 employees, 20 million a year in sales. We were controlling turbines and other processes in that business. Got very good at the intersection between quality, safety, and software development, because if you tell a turbine to do the wrong thing at the wrong moment in time, it's hooked up to the power grid, and the magnetic forces are acting backwards on the power grid onto the generator, and it will literally blow up, destroy millions of dollars of equipment, and kill people. So I got so good at that I was asked to go to Carnegie Mellon to run a research project. I was the principal investigator of several $1 million worth of research there for 7 years. I gave a talk at the Agile conference in 2009, and I got 3 job offers out of that talk. That talk was about doing metrics in the Agile world, which had largely rejected that. And so Watts Humphrey was at the Software Engineering Institute at the time, and which is at Carnegie Mellon. We came up with this concept to reintroduce metrics, and it was fairly well received. So much so that I ended up leaving Carnegie Mellon and going to work for Rally. And that's where I am now. So it took a while. That was 2009. But January of last year, 4 years later, Rally allowed me to start crawling around in the data, as Troy mentioned, of 10,000 teams to find this. Well, we were looking for 2 things. One, we were looking for a framework that would allow us to quantify the performance differences in various behaviors, attitudes, and practices. A metrics framework that was indicative of performance. And this is not easy in passively acquired data. Lots of data scrubbing work has to happen, lots of trial and error. Most of it, doesn't work out the first time. And then the second thing we tried to do is we tried to find some general correlations between the recommendations that are in the folklore for Agile and whether or not they actually lead to performance. We published that last year. We went on to build a product for Rally that actually allows you to do your own analysis on your own teams. Then we got back to doing the research again a few months ago. So I've got the next round of findings to publish now, and then we're building a full predictive model, and I'll talk a little bit about that later on in the talk. But the underlying motivation for all of this work is to give you real-world numbers so you can make an economic case for change. People don't want to change the thing they've been doing for the last 20 years. They want to keep doing it. They need some motivation. They need to know that there's at least some evidence that says it's going to be worth it for them to do it. Also, your boss will let you do a pilot maybe on something, some idea, some practice you read was good. There was a case study that said it was good. But unless you can quantify how well it does in your own environment, you won't be able to get the resources to roll it out across the organization. And this is trying to help you with that. Rally, as Troy also pointed out, is uniquely positioned to do this work. They have the data. We have the data. 10,000 teams was the study last year. 13,000 teams is the study this year. That wealth of data just, they are envious. All the other quants are envious. We can do lots of interesting things with that data. Minor differences in performance still reach statistical significance with that amount of data. Oh my goodness, the fonts didn't work when I translated this, so sorry about that. We use Google Docs and Google Slides, and these were bigger in Google Slides, but in PowerPoint they're smaller. So I'll read these out for you. Correlation does not always mean causation. There are no best practices, only good practices in context. And the quantity of alternatives rejected indicates the decision quality. So these are sort of warnings I want to give you, the first two in particular. The third bullet there is actually more of a philosophical statement on my part there. It's not sufficient to just say, we're going to do X because X is better than Y. Well, what about A, B, C, D, E, F, and G? Those might be better than Y also, and they might also be better than X. So you have to consider lots of alternatives, and it's not good enough to just say, what I'm proposing is better than what we're doing now. It's best to actually consider all the alternatives. David Snowden said something very similar earlier. Another warning, and this is a pretty big one, metrics can be used for evil. It's easy to go to the dark side of metrics. And David Snowden also spoke of this morning. Once you start to reward people extrinsically, they will no longer be motivated intrinsically, or it'll decrease their intrinsic motivation. That's essentially sin number one, manipulating others. Now, I have a whole talk on the 7 deadly sins of Agile measurement. It's done in this style, and it also has, if you can believe this, SpongeBob SquarePants characters appear throughout. It's a really great talk. I get lots of good reviews on that one. But I don't have time to go through that talk here. I just want to let you know that we are out there with content that helps you to implement metric systems and do it in a way that's not evil. And sin number one is trying to use metrics to directly drive behavior. Sin number 7 is and I swapped out, I normally have sin number 3 as my second example sin, but I swapped out sin number 7 specifically for Troy. Troy and I wrote a blog series together, and Troy's sin was sin number 7, was to try to do linear forecasting and to do forecasting without discussing probability and risk. And this is the graphic I'm nervous that you're not going to be very happy with, so let me know what you think. So the traditional way of doing a forecast would be to look at the burn up and look at the scope and draw this blue dashed line up to the point where it intersects the scope, and boom, that's the date that the team gives to management. However, there's lots of possibilities. If you in a simplest terms think about this slope for this iteration and you apply that 3.5 times, well, you'd end up here. And if you think of this most shallow slope and you apply that 13 times or so, you'd end up down here. And if you randomly picked from these various slopes, you'd end up with a distribution like this, and the 50th percentile is liable to be over here, and the 70th percentile over here. There's lots of possibilities. Throw on risk analysis, and that this shape gets bimodal and drifts out even further, and that's a much more healthy way to talk about forecasting. So these are two sins. Sin number 1 is using metrics as levers as opposed to as feedback. Sin number 7 is to use linear forecasting without talking about risk and probability. And then I'll leave you guys to find the rest of those on the web, or you can walk out of here with a poster. And we're not doing reviews, so normally I bribe you and ask you to give me a good review, positive review for the poster, but I guess that's wasted on you guys. Maybe I shouldn't even give them the poster. No. So anyway, so I have these posters. You can take it with you. They're over here. That's sin number 1. Thank you for pointing that out. That was the whole point of that exercise, actually. Okay. So the investigation continues with iteration length. So last year we published 5 different findings. Those are in a white paper. I'm going to summarize them at the end of this section. I'm going to talk about the new ones mostly in this talk, though. So those of you who hear me speak, it's going to be all new information, pretty much all new information. There's one that I gave at the Agile conference that I didn't have ready for the Kanban conference. As a matter of fact, at the Kanban conference last year, you guys suggested that I do this one, and then I got it prepared for the Agile conference. I'm going to talk about that one. That's controlling WIP, actually. I didn't have that in last year's talk here. So anyway, this is a Kanban crowd, so maybe talking about iterations is not the best, but most of Rally users are Scrum users, and about 80% of our users do iterations, either Scrumban or full Scrum. And most of them have settled on 2-week iterations, and our coaches recommend 2-week iterations, but there's a pretty wide distribution here. I'm wondering, and I'm going to do a show of hands, how many of you think that this is actually going to be the highest performing iteration length? Is the crowd wise, or are they participating in shared delusion? So those of you that think the crowd is wise and 2 weeks are best, raise your hands. Yeah, well, that's the question I'm trying to get you to ask at this point. So I'm going to answer that question right after this, is how you measure exactly. But let's play along with me for just a little bit. Let's have some vague concept of performance. And which ones perform best? Does the 2-week iterations perform best? We had a few hands go up. Let's see those again. Let me count them. 1, 2, 3, 4, 5. Okay. How many people think that 2 weeks are not best? Wow, the vast majority. What do you guys think? What do you think is best?
I'm a flow guy. So.
Oh, okay. Well, that's not an option here.
1 week.
1 week. Okay. Single piece flow, closer to that. Anybody else have something other than 1 week? Dan?
I think 2 weeks is too short to actually deliver something deliverable.
So, yeah. I don't. That's very good. Let's hold on to that, because I can help you with that intuition and confirm it actually in a little bit here. So.
Are we allowed to develop a flow system inside our 5+ week iteration?
Yeah. That would win, yeah. So I do have evidence on controlling WIP, so you guys, and it's very good, positive, well, mostly, 3/4 good. So we'll talk about that in a little bit. Last year I showed you the data that compared Scrum to Kanban in a sneak peek mode at this talk, but I don't have that published, because we only have a small percentage of folks that we think are doing Kanban well, so I didn't feel like we had a good sample. This could be either. This data could be either. So let's move on. Let's answer the question. Turns out that the crowd actually is wise. So 2-week iterations have the overall peak performance. And I intentionally give you the answer to one of these without telling you how I did the measurement, because I want you all now asking the question, how did you do the measurement? And we've got these 4 dimensions here: predictability, productivity, quality, and responsiveness. These are 4 of the 7 dimensions that are in this thing that we invented called the Software Development Performance Index. Notice it doesn't say the Agile or the Lean Development Performance Index. We're going to use this to measure software development teams, whether they're doing Agile practices or not, whether they're doing Lean practices or not, whether they're doing Kanban or not. And we're going to compare each of the practices, behaviors, attitudes on performance. That's the idea. The 7 dimensions are the 4 that I just mentioned, these 4, plus there's 2 that we're adding this year: customer satisfaction or stakeholder satisfaction, employee satisfaction or employee engagement, and then one that we're noodling on, and hopefully we'll have something in 2015 on, which is something we're calling the build the right thing metric, or some people like to call it the value delivered metric. And we've got a couple ideas on how to do that, working with a partner on that. So I stacked them. I stacked those 4 dimensions. One, defect density is measured in defects per 1,000 man hours, and time and process is measured in working days. How can you add those 2 dissimilar units into an index? Well, I convert the raw metrics into percentiles, and then I can add them that way. So what I do is I take the raw metric for throughput, the count of stories finished in a given month or a given quarter, and I look at all the teams, what their throughput was, and I created a distribution. I normalized by team size. I pull some stuff out of the distribution as outliers. We do all the cleaning we can on it, and then we create this this distribution of percentiles. So just like if your kid comes home from school and he says, I was in the 98th percentile for this standardized test, he might have only got 90% of the questions right on the test. It doesn't matter whether he got 90% of the questions right on the test. It matters that he was in the 98th percentile. That's what we're using here to come up with the scores, is these percentiles. And so that's how we stack them.
Isn't the productivity more about activity than value? I mean, it's not really something that should be in a performance.
Yeah, so we have these 7 dimensions of the performance index. 4 of them I can automatically extract from this huge database, and these are the 4 I'm focused on right now. The value delivery one is one we want to add to the system, but we don't have it right now. So that's a limitation. We'd rather publish than not publish. We'd rather deliver what we can. We can deliver this now, and that's what we're doing. Now, we did do a lot of work to validate that each of these 4 raw metrics correlated with qualitative input on these. So the teams that got the highest scores from their management for productivity had the highest throughput generally. The teams that had the best predictability had the best stability. We compared metrics to other metrics that we could only calculate for a subset of the teams. So for instance, for predictability, we can calculate on-time delivery for some teams if they're using the tool in a certain way. We can calculate say-do if they're using the tool in a certain way. The stories that they say they're going to do an iteration, how often do they actually do those stories? And so we correlated those, we did principal component analysis on it. We actually calculated 120 total metrics and narrowed it down to these metrics for the research. And we actually support generating and using and getting feedback on all 120 eventually. Right now, 45 are surfaced in the tool. So that's how we add them up. Now back to iteration length. So let's poke down to each of these dimensions one at a time. This is the productivity dimension. And you can see that there's a fairly significant difference between productivity of the smallest team, the shortest iterations, and the longest iterations. There's a fairly wide range. This is the P25 to P75 range here. And it's because they're percentiles, this is actually a P50 here. So this is the median score for that group. But there's a very significant difference in productivity between the shorter iterations and the longer iterations. Thank you. Looking at quality, though, you see that the peak is at 4 weeks. So what we found last year is that larger teams had better quality and worse productivity and responsiveness. What we're finding this year is that longer iteration lengths have better quality and worse productivity. It seems to go together. The underlying mechanism we think is happening in both places is you have more time and you have more people to do things like design review, code review, testing. And that's why if your economic model is such that quality is driving your bottom line, like you're a medical device manufacturer, for instance, or you're writing software that controls aircrafts, people's lives are on the line, you want to probably have longer iterations and you probably want to have more people on your teams dedicated to those quality roles. If you're a game manufacturer or a mobile app manufacturer, then maybe you want to move fast and emphasize responsiveness and productivity. And in that case, you'd have a different answer for what you do. One thing that's interesting here, though, is the delta in quality is fairly large for 1 week iterations. And when you go over here to responsiveness, the delta is by far and away the largest stick of these. So the range of responsiveness performance for the folks doing 1 week iterations is the widest. Although, you'd expect to have better time and process for shorter iterations. That just makes sense. But it looks like there's some folks that are doing this at a machismo, that they say they're doing 1 week iterations, but they're not, because the lower 25 percentile folks doing 1 week iterations actually has worse responsiveness than 2 week iterations. So there's an anti-pattern that coaches talk about. Maybe, Bruce, you've seen this, where folks are doing an iteration where they produce work, and then the next iteration they harden it, and then they go back to producing work, and then they harden it. And they're not really completing the work in an iteration. They're taking 2 iterations to actually complete the work. So that was interesting. Just to give you a little bit of flavor of some of the analysis we do behind the scenes, that we don't publish all of this, we do what's called within subjects analysis on each of these findings as well. So we look for teams that switched from 2-week iterations to 3-week iterations, and we have 107 of those that had statistical significance for the average responsiveness score, and then folks that switched from 3 weeks to 2 weeks. And you want these two lines to cross. And the reason within subjects analysis is really highly desired by us statistical analysis folks is that you're controlling for a lot of things that way. They have the same code base, they have the same people, they have the same organization, all that stuff is controlled for. And you can pretty much assume that the thing that changed, the only thing that changed is the length of the iteration. So this is the moment, T0 is the moment where they made the change. This is 1 month before, 2 months before, 3 months before. This is 1 month after, 2 months after, 3 months after. And so there's a 5 percentile spread here and a 10 percentile spread here. This is about a 15 percentile point spread within subjects. This is a very significant finding for within subjects. And we did the same thing for productivity. This is about a 2 percentile point delta here and about a 3 here. So that's about a 5 percentile point delta in productivity. The other interesting thing about this chart, though, is that these folks were already improving, the folks that switched from 3 weeks to 2 weeks, and they kept improving after the switch, and were still improving. My conclusion there is that it's fairly likely, there's good evidence, fairly likely, that the switch to 2-week iterations was a symptom of them getting better and not the cause of them getting better. And so this is likely not a causal relationship, at least for this particular outcome. Although the folks that switched the other way got worse. So either they were getting worse, probably not. Maybe switching iterations caused them to get worse. So it's causal in one direction and not in the other, which is sort of strange. These are the summary slides for you to print out and have. I'm not going to read them off because I've essentially said everything that's on those as we go. So this is the one I didn't publish at this talk last year. This is controlling WIP. So the group over here has 7 or more work items in process at the same time, and the group over here has 1 or less, probably doing some sort of pair programming. And this is the most obvious finding in the whole deck because this is essentially what Little's law predicts, queuing theory Little's law. There should be a linear relationship between WIP and TIP. And so nothing new here, not very interesting here. But this was probably the most surprising finding in the study last year. Not that there was a correlation between controlling WIP and quality. We expected that. But the magnitude of this correlation is almost 4 to 1 from the worst case to the best case scenarios here. And I'm still doubtful that this is completely causal because it seems like a very, very dramatic difference in defect density just by controlling WIP. The theory here is that if you have fewer things you're working on, you concentrate more, you have more people essentially focused on the quality of that one thing, and you produce a better thing. That makes sense. We're pretty sure that effect is in place, but I'm wondering if there's not another effect under the covers here as well.
As a coach, low WIP means the team has to collaborate. And one of the things in Agile that we at least think might be a cause would be if you get developers and testers kind of pairing and working more closely together, you'll get better quality results.
Maybe that's what happened. I don't doubt the finding has at least some causality to it. It's just the magnitude is so much bigger than anything else in the study that it makes me wonder a little bit. So
you talk about determining causality. How are you doing that? Because you say this is causal, this isn't, but what
well,
do you use?
there's actually no way to say conclusively if something is causal. What we do in statistical analysis is we try to come up with theories that explain the data. And if the theory, if you have 3 or 4 theories that explain the data, and one of them is the one that you want to be true, the thing on the x-axis is why the thing on the y-axis is behaving that way, then what you do is you try to come up with analyses that disprove the other 3 that you thought of. You try to control for the other variables, essentially, is the way you do that. And so that's how we try to rule out causality. So we did do, and there's an appendix in the white paper that talks about all the other things we tried to rule this out as being a non-causal relationship. And none of those panned out, which means that this is so far the only theory we have is the causal theory for why this is the case. So if any of those other things had panned out, then we would have said, you know, hey, just like I told you here on the earlier one, that those teams were improving anyway, the ones that switched to 2-week iterations. So I didn't rule that out. I actually have that evidence that says they were improving anyway. And I'm going to move on and hold it for the end, and we'll come back to it. We only got 10 minutes left before the questions. So this is probably the most interesting thing that we published last year. And this is also predicted by queuing theory. What this says is that you can push WIP too far. If you push WIP too low, you negatively impact productivity. And this makes sense, because specialized folks, their queue might be empty and they have nothing to work on. If you get blocked, there's nothing to pivot to. So in order to make a decision on what to do, you have to take your economic model into account. This is the summary slides. Moving on to the ratio of testers to developers. So all the research we did last year, we got both the behaviors out of the big data set and we got the performance out of the big data set. This year, we actually went out with surveys. We now have about 600 surveys in, and this data is a little bit earlier, so this isn't quite the latest and greatest in this slide here. And we filter some of those out as people just filling out the survey sloppily and just phoning it in at the end. But we see we have about 500 good surveys now, and there's not quite, you know, maybe not even 200 up there represented. So we have a lot more statistical significance now than I'm showing here. But what you have here is these are folks that self-identified as having no dedicated testers on the team. These are folks that self-identified that they have about a 1-to-3 ratio or less of testers on the team. These are folks that identified roughly 1-to-2 ratio of tester to developer on the team. And these folks are approaching 1-to-1 ratio of tester to developer on the team. And this is the fewest number. And 1-to-2 is surprisingly the biggest number of folks that we had. So there's more testers than I think we assumed, dedicated testers on the teams than I think we assumed. And the results that we get are generally what we expect, with one exception. So the folks with more testers on the team generally had better quality. When you go from here to here, it's better quality. When you go from here to here, it's better quality. However, the folks that identified with no dedicated testers actually had roughly the same median quality as the folks with, you know, almost a 1-to-1 ratio of testers. So these teams are really owning the quality. And so another thing to look at here, though, is the spread. So there's some folks that are not owning it at all. They're doing a lot worse than folks with even minimal testers. So the lower 25th percentile in this group is actually doing worse than having one dedicated tester. But the upper 25th percentile and the median is actually doing better than even the folks, well, everyone except for the 1-to-1 ratio folks. Yes? Quality is defect density. Were you here when we went over that part? Okay. So moving along, you'd expect productivity to be reduced by dedicated testers. So generally, we have a downward slope here. With the fewer testers you have, the higher the productivity, and this as you expect. So you have to make a trade-off between quality and productivity.
Total performance, that's the blend.
I didn't do total performance, actually. This is how many people self-identified with. This is just the count. This is just the histogram. This is not total performance. This is not total performance. I would show that stacked. Sorry, this is just the count. Thank you for catching me there. Okay, I'm going to move on really fast. Motive. So this is the count at the top of people that answered enhanced software quality as the primary reason for adopting Agile. Organizational decision, they were told to adopt Agile, is this second one, and it's the biggest one. This one down here is accelerate time to market. That's a one you expect to get. And then managing changing priorities, that's another one you expect to get. Interestingly, though, they were told to adopt Agile is the biggest reason for adopting Agile. And it's the second highest performing group. Now, there isn't huge differences in overall performance between these groups, though. So, but the one that we were interested in seeing is that enhances software quality is not given as a big reason very often, but those groups, the ones that are motivated by that, tend to have the most performance overall. I don't think this is causal, and I haven't ruled out all the theories, but I think it's just people that naturally choose high quality tend to naturally have higher performance. It makes sense. We've got studies that say that. So the reason for success given, great teamwork is the number one reason by far why teams think they are being successful, the success they've achieved. Exceptional skill or talent, however, is, if that's why you think you're successful, if you highly value that, then those groups tend to perform the most. And there's lots of older studies that confirm this. Kokomo essentially said that the skill of the individuals on the team is the number one driver of performance. And this tends to back that up. I think that is causal, actually. Geography. And so there's some folks in here that are going to be really happy about this, and some folks that are not going to be so happy about this. And I looked at two of them just now here. So again, there is not huge differences here in geography, but the folks from down under, any of you Aussies here?
How do we still define performance in software or in other?
Yeah, well, no, we're still talking about software. So. Had the best, and New Zealand was included in this, by the way. And India had the worst performance overall, sorry to say. I've got a couple of drill downs here that I find pretty interesting. If you look at the Israeli numbers for quality, this is the defect density of defects released to the field, and they had the best in production quality of any of the groups. But they reported the second most defects during testing, internally. And India had high for both of those. So I think there's a reporting bias going on here, especially for India. I think because it's an outsourced situation, they're expected to record the defects in the tool and use the tool to its maximum degree, and you have a bit of a recording bias there. So we're hurting India a little bit here. But the ratio of defects found in tests to the defects released to production is off the charts, maybe 6-to-1 better than the next best one for Israel. And the thing that's interesting about this is that the Israeli teams that I know of that are using Rally, and it's not very many, it's maybe 30 or 40 teams that are using Rally in Israel. A big portion of them come from one company, and they are heavy into static analysis, into continuous code inspection. So I'm trying to figure out if there's a correlation between the use of static analysis tools and this defect removal effectiveness ratio.
Static analysis ones is real defects, or it's different?
I don't think they do, actually. So that doesn't help explain why this number is so high. So but I have to work on that a little more to sort of work that out. Yes. So this is a summary of the findings from last year. Keep your team stable. Dedicate people to one team. Smaller teams have better productivity, but larger teams have better quality. We mentioned that already once. Motive has a small... these two slides are swapped. That was supposed to be before the other slide, so never mind that. Moving on to future work. The saga continues. I have a tool. We don't have time to do a demo, but if you want to come up later, I'll be glad to show you the tool, or you can, if you're a Rally user, you can actually do these analysis for your own teams. We're adding 30 more variables. 1 minute, thank you. I'm on my last slide here, so that's good. We're adding 30 more variables. I talked about 5 or 6 of them in this deck. I have another 25 or 30 sort of in analysis. We should publish most of those by the Agile conference. So the volume of findings is going to come out much more rapidly as we move forward. We are adding survey-based assessment into tooling. We're not just sending that to Rally customers in this next round. We're sending that to non-Rally customers. So we'll be getting a sampling from other places, and that's going to give us the 2 extra dimensions of employer or stakeholder satisfaction and employee engagement. Customer or stakeholder satisfaction and employee engagement. That's these 2. And then we have a fully predictive Bayesian model now with all these variables. You take this survey, and I can predict with some degree of certainty what your performance is likely to be. I don't even have to actually measure your performance in the tool. I can predict, just based on this regression model, what your performance is likely to be based upon your answers to these surveys. Now, it's not perfect, and it's a pretty wide range of performance, but I can get you benchmarked in a quartile for each of these dimensions pretty accurately. 90% of the time, I can get what quartile you're in pretty accurately. So we're using this to develop a new product, not just research and theory, but you'll be able to take this survey, and you don't even have to be a Rally user. I can predict what your current performance is likely to be, and I can do what-if analysis, and I can say, these are the top 5 things you should do next to improve your performance. We'll have a baked-in coaching, baked-in recommendation engine capability, and you don't even have to be a Rally user to get it. Did I say that? You don't have to be a Rally user to get it. So, so I'll end with a little bit of drama, and then we'll do questions. A fact without a theory is like a ship without a sail. It's like a boat without a rudder. It's like a kite without a tail. A fact without a theory is a tragic final act. But one thing worse in this universe is a theory without a fact. We've been operating on theory and folklore and intuition for a long time now. It's time to actually put some facts to it. Thank you.
Did you spend any time looking at those outliers that you said you threw out?
Yeah.
I wonder if there's any, there's like some of those 10x programmers that are hiding in there.
Well, we actually did a study last year where we looked at the performance of a team moving with individuals, and we were able to identify individuals that moved from one team to another, that their top performance, the performance went with them, and then we were able to identify folks where the bad performance went with them when they went to a team as
I
well.
was really more asking generally if you found unusual things that you could follow up on any of the outliers that you passed out. And was there anything interesting there, or were they just lying?
Well, one of the conditions of the big data analysis research is that the data is non-attributable. So we don't know who it is, so we can't trace it back to individuals, even if we wanted to. Yes?
You probably know what I'm going to ask, but
Pair programming, maybe?
no, actually, test-driven development
Test-driven.
recently declared dead.
Oh, yeah, I've been reading that stuff. Yeah, so.
Do you have any sort of data on whether it's like
And this is probably a little risky, but I'll pull up sort of my early analysis on it. No cameras, please.
Yeah, none of us have got Twitter.
None of us have got Twitter. I don't have enough time? Yeah, it might not all come up, actually.
So it's all done in Excel.
Yeah, it's all done in Excel. No, so we're doing the research in a very careful way, and we're going to publish in a very careful way. And I have to have the VPN to even show it, so I can't even pull this up for you guys. Sorry about that. So it's on the VPN. So most of the engineering practices are highly context sensitive. They have very wide ranges of performance impact. I think that there's people that are doing it well, and there's people that are not doing it well. There's people that are doing it in the right context and people that are doing it in the wrong context. And I can't say in general, though, that those practices lead to better performance. In fact, in most cases, they lead to slight improvements in quality and significant decreases in productivity. And so I want to caution you on use of those things, because if that's the general case, if your application of it is the general case, you're likely to have trouble getting great performance out of it. Now, if you do it well, though, it seems to be that the top 25th percentile of those outperforms the top 25th percentile of the other. So I'm trying to find discriminators that will say these are the contexts where it works well and these are the contexts where it doesn't. And when I have those, I will publish. Pair programming and TDD are both in the same bucket. So, other question?
We've done quantitative studies on many TDD projects. It reduces defects by a fourfold. So it is an enormous productivity improvement, quantitatively shown. And so I don't know what the research is showing, but I think we need to talk about it.
Is it self-declared? I mean, do people say, we use TDD?
Yeah, yeah.
And so we don't even know whether they actually.
Well,
write
the
it.
question in my survey is not, do you use TDD? The question in my survey is, do you write the tests before you write the code? I have different questions about coverage of automated testing. Those tend to be positive in both productivity and in quality. The use of automated test suites and continuous integration. Those are not controversial in my study. But the application of writing the tests before you write the code does not tend, in the general case, to huge improvements. In fact, in some cases, it leads to decreases in what I'm finding so far. And that backs up other studies. Capers-Jones, that's his data as well. So
So we're out of time.
okay, great. Thank you.